Good morning, everyone. My name is Joshua Phillips, and I'm excited to present my senior capstone project to you all. My project is a case study analyzing energy efficiency, water quality, and design of new and old buildings here on the University of Arizona campus. This study focuses on a question that's becoming more relevant each and every year. How sustainable are the buildings we already have, and what role does age play in their environmental performance and their overall sustainability performances? Here at the University of Arizona, we have a crazy range of buildings all the way from the 19th century to brand new structures with LEED certified modern facilities. This makes it a perfect place to conduct this type of research. As for my research question, I focused in on a main question about how does building age impact energy consumption and water quality? And to dig a bit deeper, I asked these questions as well. Do older buildings perform worse when it comes to sustainability benchmarks like water safety and energy efficiency? And more importantly, can adaptive reuse be just as sustainable as tearing down the old buildings and building new ones? This study aims to offer practical insight into these questions using real-world data with 8 different buildings around campus selected to represent a balance between older and newer construction. As for my methodology, I used mixed methods approach, combining field work, data analysis, and on-site infrastructure observation. First, I conducted water quality tests in each building. I measured things like chlorine levels, total dissolved solids, turbidity, pH levels, and the presence of copper and iron within the water. Second, I collected and compared monthly energy usage data for each of these buildings, including electricity and gas. This helped me assess how efficiently each building operates over a time period. Finally, I performed site-level infrastructure reviews, looking at the age, design, and overall state of each building. The buildings studied range from Old Main, built in 1891, all the way to the brand new ENR2 LEED Platinum certified structure, which has been built in 2015. This crazy range helped me reveal how sustainability performances have evolved over time. Now, for my key results, water quality findings, I found that older buildings, especially Old Main and Yuma Hall, had higher total dissolved solids. These levels were well above the newer buildings like Arbel in the Bass building. This suggests that aging pipes and infrastructure degradation are very much so contributing factors to water quality. Heavy metals like iron and copper were also slightly elevated in the older facilities, which is consistent with older plumbing systems and older pipes. So overall, while water across all the buildings remained within safe ranges, older buildings did show signs of wear in their internal systems, which will affect water quality over a long-term time frame. As for my energy use findings, I found that older buildings, particularly Old Main and Harble, were significantly more energy used significant energy per square foot. Sorry about that. These buildings most likely have outdated internal systems, poor insulation, and less effective lighting, all of which contribute to much higher energy demands. In a big contrast, the newer buildings like ENR2 and the Arbel Residence Hall are much more efficient. Even though they are larger structures, they have newer systems, and this shows how those modern systems and design standards make a huge impact. It's also worth noting that newer buildings may consume more energy due to their size and how big they are compared to the older buildings, but their energy intensity is far lower, and that's a key sustainability metric. And so you're probably asking, what does this all mean? First, it confirms that building age strongly influences energy efficiency and to a lesser degree, water quality. Second, it highlights the modern design and updated infrastructure make a huge and measurable difference. And third, it suggests that retrofitting older buildings isn't just a good idea, but it really is essential to bring up legacy infrastructures to our modern sustainability targets. With all that said, not all older buildings performed poorly. Some already had minimal upgrades, some had new windows, more efficient lighting. Those all helped close the performance gap of these buildings, and it shows that older buildings can be made more sustainable. As for some Key takeaways and recommendations based off my study. Newer buildings consistently outperformed older ones in both water system performance and energy use. Building age does matter, especially when it comes to energy. Water quality differences, while they were present, they were not severe, and this is mostly due to a centralized treatment from the university and maintenance and governmental protocols that are on water quality. And finally, strategic retrofitting can most likely bring older buildings much closer to our modern performance levels that we expect. I would recommend that the university focus on retrofitting high-use older buildings first, incorporating real-time energy monitoring, and designing upgrades that balance performance with preserving that old architectural style. And this goes for not only university buildings, but any building in the world. You can apply these anywhere you go. Contributes to the growing evidence of adaptive reuse, and if paired with smart retrofits, can both be sustainable and cost effective compared to building a completely new building. And I'd like to thank you guys all for your time, attention, and I'd like to acknowledge